From the outside, a tow truck looks almost embarrassingly simple. There is a cab in the front, a steel platform or lifting arm in the back, and somehow a broken car ends up being carried away. But watch one closely and the whole thing starts to look a lot stranger. The bed slides backward, then tilts toward the ground. A hydraulic cylinder underneath the truck somehow lifts several thousand pounds of steel and vehicle at the same time. A cable pulls the disabled car up the platform, the bed levels itself, and within minutes, the tow truck drives away carrying another entire vehicle on its back. That sounds straightforward until you realize what the truck is actually doing. A normal sedan can weigh around 2 tons. SUVs and electric vehicles can weigh significantly more. A heavy-duty recovery truck may need to lift part of a bus or tractor trailer weighing tens of thousands of pounds, sometimes while that vehicle is upside down, stuck in mud, or halfway down an embankment. And yet one operator can control all of this with a few levers. The secret is not that tow trucks are absurdly powerful. It is that they are very good at turning relatively small amounts of movement into enormous amounts of controlled force. That begins with hydraulics. The flatbed on a rollback tow truck looks like one solid piece of steel, but underneath it is a network of hydraulic cylinders, pivots, rails, and high-pressure lines. When the operator moves a control lever, they are not directly lifting the bed. They are opening a valve that allows pressurized hydraulic fluid to move through the system. That distinction is important. Liquids are extremely difficult to compress, which means force applied to hydraulic fluid can be transmitted efficiently through hoses and cylinders. Inside each cylinder is a piston. Push pressurized oil into one side and the piston extends. Send the oil to the opposite side and it retracts. The cylinder itself may not look large enough to lift a loaded flatbed, but hydraulic systems operate at very high pressure. Combine that pressure with the surface area of the piston, and the cylinder can generate an enormous amount of force. It is the same reason a hydraulic jack small enough to fit in a garage can lift a car. But the tow truck adds another advantage: leverage. The cylinder is not simply pushing straight upward underneath the middle of the bed. It connects to the platform through carefully chosen pivot points. That geometry lets the hydraulic force rotate the bed around its hinges, much like using a long wrench lets you turn a bolt that would be impossible to move with your fingers. This is why the flatbed seems to rise effortlessly even with a car sitting on it. The system is not overpowering the weight. It is using pressure and geometry to make the weight manageable, and the bed does something else before it tilts. It slides backward. That might look unnecessary until you imagine trying to drive a low sports car onto a steep metal ramp. If the platform simply pivoted downward from its normal position, the angle could be so sharp that the car's bumper or underbody would scrape the pavement before the wheels even reach the bed. Sliding the platform backward first changes the geometry. The rear edge moves farther away from the truck, allowing the bed to meet the ground at a shallower angle. Once the platform is extended, the front rises and the rear drops until it creates a long loading ramp. Now the truck has turned itself from a vehicle into something closer to a portable loading dock. But the disabled car still has to climb that ramp, and this is where another hidden machine takes over: the winch. Mounted near the front of the bed is a motorized drum wrapped with steel cable or synthetic rope. The operator pulls that line toward the disabled car and attaches it to a structural recovery point. Then, the winch begins winding the cable back in. At first glance, it seems like the winch is lifting the entire car, but that is not really what is happening. Most of the vehicle's weight is still supported by its tires and the ramp. The winch mainly needs to overcome rolling resistance, gravity, damaged wheels, and the slope of the bed. This is a bit like pulling a refrigerator up a ramp instead of trying to pick it straight off the ground. The refrigerator still weighs the same amount, but changing the direction of the force makes the job dramatically easier. The difference is that a tow truck may be pulling several thousand pounds, and sometimes the vehicle does not even want to roll. A crashed car may have a locked transmission, bent suspension, flat tires, or wheels pointing in completely different directions. In that case, the operator may use smooth recovery skates beneath the tires, reducing friction enough for the winch to drag the car onto the bed without destroying the platform or suspension. and suddenly one of those random-looking tools in the side compartment has a purpose. That is how almost everything on a tow truck is arranged. It is not there because the operator might need tools. It is there because every broken vehicle creates a slightly different physics problem. One car may roll freely but have nowhere safe to attach a cable. Another may have its front suspension collapsed onto the pavement. A third could be sitting at an angle where pulling it directly would drag it into a guardrail. So the operator changes the rigging. Hooks and shackles create secure connection points. Chains can attach to structural parts of the vehicle. Pulleys can redirect the winch line or even multiply the pulling force. Blocks can change the vehicle's angle or protect low bodywork. The truck is not just towing the car, it is building a temporary lifting system around whatever problem is in front of it. That becomes much more obvious with heavy recovery. Imagine a tractor trailer that is rolled onto its side. A normal tow truck cannot simply back up, attach one cable, and pull. The overturned truck may weigh tens of thousands of pounds. Its cargo may have shifted completely to one side. The pavement could be wet, the shoulder could be soft, and pulling from the wrong direction could make the recovery truck itself slide or tip. This is why heavy wreckers deploy outriggers. These are stabilizing legs that extend outward from the recovery truck and press against the ground, widening its effective base. Instead of depending only on the tires for grip and stability, the truck can transfer some of the pulling forces directly into the pavement. Now, multiple winches can be used at the same time. One cable may begin lifting the overturned truck while another controls how quickly it rotates. Another line might stabilize the trailer so it does not swing once the vehicle starts moving. This is less like towing and more like performing surgery on a giant machine. Every cable has to be loaded in the correct direction. Every attachment point has to withstand the force. Every movement has to be predicted before the winches start pulling, because once several tons of wrecked vehicle begin moving, stopping that movement is much harder than preventing the wrong movement in the first place. Pulleys make this even more interesting. Suppose the tow truck's winch does not have enough pulling force for the recovery. The operator can route the cable through a pulley attached near the load and then back toward the truck. Now the system pulls with more mechanical advantage. The trade-off is that the winch has to reel in more cable for the vehicle to move the same distance, so the recovery becomes slower. But in heavy towing, slow is usually exactly what you want. The goal is not to yank the vehicle out dramatically. The goal is to move it a few inches at a time without anything unexpected happening. Once a car is actually on a flatbed, another problem appears. The vehicle has to stay there. The winch cable alone is not enough because the truck will accelerate, brake, turn, hit potholes, and potentially travel at highway speed. Several thousand pounds of car cannot be allowed to shift freely on the platform, so the vehicle is secured using wheel straps, chains, or other restraints that lock it to the bed. This also explains why position matters. If the vehicle sits too far toward the rear, too much weight can be transferred behind the tow truck's rear axle. That can reduce the load on the front wheels, making steering worse and potentially overloading the rear suspension and tires. Move it too far forward, and the front or rear axle can be overloaded in a different way. The truck has a safe weight envelope, and the operator has to place the vehicle so that load is distributed correctly. This is why tow trucks have strict ratings. A truck designed for passenger cars cannot simply attempt to carry anything that physically fits on the bed. The hydraulic cylinders may be able to move it, but that does not mean the chassis, brakes, tires, axle, or suspension can safely transport it. The same idea explains why there are so many different types of tow truck. A flatbed is excellent when a vehicle should not roll on its own wheels. That makes it useful for all-wheel drive cars, badly damaged vehicles, low sports cars, and electric vehicles. A wheel lift truck solves the problem differently. Instead of loading the entire car onto a bed, a metal assembly extends beneath either the front or rear wheels. Arms capture the tires, and hydraulics lift that end of the vehicle off the pavement. Now the car behaves almost like a trailer. But this creates a hidden problem that did not matter on older cars nearly as much. Modern drivetrains. If the wrong wheels remain on the road, the tow truck can force components inside the transmission or differential to rotate while the engine is off. On some all-wheel drive vehicles, this can cause serious damage. That is why operators need to know what they are towing before they lift it. Sometimes they use small auxiliary dollies underneath the remaining wheels so none of the vehicle's own tires have to rotate on the pavement. Again, the truck is not simply picking up the car, it is adapting to the vehicle's mechanical design. Electric cars add another layer. Large battery packs make many EVs heavier than similar gasoline vehicles, and manufacturers often specify exactly how they should be transported. A damaged high-voltage battery can also create hazards that change how recovery crews approach the vehicle. A flatbed is often the simplest solution because all four wheels are completely off the ground and nothing in the drivetrain needs to rotate. But even after the vehicle is loaded safely, the tow truck's job is not finished. Now it has to drive. Adding thousands of pounds changes everything about how the truck behaves. Acceleration becomes slower, stopping distance increases, suspension loads rise, and turns have to be taken more carefully. A wheel lift truck also becomes significantly longer once another vehicle is hanging behind it. The driver has to account for that extra length every time they change lanes, back up, or turn through a tight intersection. Heavy wreckers towing buses or tractor trailers face an even bigger version of this problem. Some systems can connect into the disabled vehicle's air brakes so the towed vehicle helps slow itself. Otherwise, the recovery truck could be responsible for stopping an enormous amount of extra mass using only its own brakes. That is where the tow truck stops looking like a clever piece of hydraulics and starts looking like a complete transportation system. It has to lift the load, control the load, secure the load, and then safely stop the load. Every part of the machine is designed around one simple reality. Moving something heavy is only useful if you can control what happens after it starts moving. That is also why tow operators are so careful around winch cables. A cable under heavy tension is storing energy. If it snaps, that energy can release violently, causing the broken cable to whip across the recovery area. Operators inspect cables for damage and avoid standing directly in their line of pull whenever possible. The same principle applies to chains, straps, hooks, and shackles. Every piece has a load rating because a recovery is only as strong as its weakest connection. One tiny part failing can instantly turn a controlled pull into an uncontrolled one, which is probably the biggest misconception about tow trucks. The impressive part is not that they can pull hard. A lot of machines can pull hard. The impressive part is that a tow truck can create enormous force and then control that force precisely enough to move a damaged vehicle inches at a time. The hydraulics create the lifting power. The bed geometry creates leverage. The winch turns rotation into pulling force. Pulleys can multiply or redirect that force. Stabilizers prevent the recovery truck from becoming part of the accident, and the operator combines all of it depending on the situation. From the outside, most of those systems disappear. The bed lies flat. The hydraulic cylinders are hidden underneath. The winch is tucked behind the cab. The straps and rigging sit inside compartments. It looks like an ordinary truck carrying a steel platform. Then, it reaches a broken vehicle. The platform slides backward and tilts toward the ground. A cable extends across the pavement. The disabled car begins climbing the ramp. Hydraulics lift several tons back onto the chassis. The platform locks into place, and minutes later, the tow truck drives away carrying another machine that could no longer move itself. And that is what makes a tow truck much more interesting than it first appears. It does not simply tow cars. It temporarily transforms itself into whatever machine the recovery requires. A loading ramp, a hydraulic lift, a winch, a crane, a stabilizing platform, and finally, a transport vehicle, all controlled by one operator moving a handful of levers while pressurized oil, carefully positioned pivots, and mechanical advantage do the heavy work underneath. That is how a tow truck actually works.